Hello, my name is Noah D'Souza, and this is my Physics 2211 Lab 4. So the purpose of this lab was to analyze the motion of a spring mass system where the mass is oscillating. I used the tracker to track the position of the mass and GlowScript to create a computational model of the object's motion. The goal of this lab was to determine the accuracy of the model and show the energy principle. Oh my goodness. Principle. This is done by looking at the system's total energy and making sure that it stays zero. Two of the main equations I used here were Newton's second law and the energy principle, of course. And then this is just a screenshot of my tracker. So I put the option one video into the tracker, went through frame by frame, and clicked on where the mass was. And that gave me all these little red dots over here, and it also gave me these two graphs with a whole bunch of data, but I didn't paste all the data. It was like 100 lines. Um, okay, so basically what this is it's the x position of the mass versus time and the y position of the mass versus time. And some info. So the mass was 0.402 kilograms, length of spring 0.7 meters, initial position was negative 0.165, negative 0.8820, because we're treating this as just 2D instead of 3D. And the initial velocity was zero because it started from rest. The time per cycle, so like the oscillation period, of the mass was about 1.3. Stiffness is 6.872, and L0 is 0.1261. Some of the code that I got here is these are just the lines that I edited. So the mass of the ball, position, velocity. These are all the initial conditions. And then we have some constants. So gravity, spring constant, which I found before, relaxed length of the spring, which I found before. And then it's calculating the some of the information about the spring. So L, L hat, and S. And then it's calculating the energy stuff. So first kinetic energy, then gravitational potential, spring potential, and total energy, which is obviously just the sum of all the other energies. And then this is the actual loop. So we're looking at F grav. So we have gravitational force, we have spring force, and then we have net force, which is just the sum of those two. Also, then we apply the momentum principle, so Newton's second law, and that updates the position of the ball or spring in this case, or sorry, mass. So we have ball velocity and then ball position, and then updating the spring. So that's kind of what we did before, just now in the calculation loop. And then finally calculating the energy changes. So K, delta K, UG, delta UG, US, delta US, and then E and delta E. So that's change in energy, and that's actually what we want to look at. So first we have the model versus the actual. So the computational model, you can see that it was pretty accurate. It's pretty close to what the tracker actually mapped out, and the results of this. So the change of energy versus time. So you can see that delta K, delta U, grav, and delta U spring are all kind of oscillating, but delta E is staying constant at zero. So this means this is the answer to the questions. So the energy principle is satisfied because the change in energy is always zero. The oscillation period estimates the x direction. So for estimating the oscillation period, when you estimate the x direction, you get about 5.62, and estimating the y direction, you get 6.87. So this tells you that the different directions give different answers. Um, and that's all for my lab. A couple points of where I could have messed up would be in the tracker, not properly clicking on where the center was every single time. And also, I treated this as 2D when in reality, obviously, it's 3D. So those could be two little points where mistakes were made. But other than that, thank you so much for watching. And yeah, that was my lab 4.